Hello, virtual friend. My name is Emilio, and I'm a hacker. I enjoy playing with the networks, firewall, protocols, electronics, and also 3D printing. I present tools at various conferences around Asia, Europe, and America. I'm originally from Argentina. That's the reason my Argentinian English, and I'm living in Japan, so I'm 1 hour ahead of Singapore. This talk is called Misuse of DNS, the second most used protocol, right? This is based on layer 4, so the first most used protocol will be HTTP, and hence DNS will be the second one. DNS been a while, 1987, RFC 10, 33, 34, 35, been out. So it's been attacked and used a lot, basically. So I will give you an overview of the attacks in the past, currently on the past, and I split it in categories like server side, client side, and protocol. So from the server side, we have buffer overflows, we have a denial of service, distribute denial of service, amplification attacks. On the client side, we have a cache poison, man in the middle. We also have a DNS rebind, which is useful to access internal websites via the client, right? And on the protocol itself, I don't know if you remember, but we used to be able to transfer zones from a DNS, open and misconfigure bind back in the days. These days we have more common tunneling and command and control, we're going to be focusing here, right? Well, what has been done on DNS, right? DNS, there's been a lot of security in DNS. We have the DNSSEC, which is dated back 2005, and actually is quite complex to implement based on root signing, key management, validation. It's a bit complex, and it doesn't really provide privacy. It's just mainly validation, so for tampering domains, or authenticate domains and answers, basically. Then we have DNS over HTTPS, DO, actually called. The idea was to encrypt the client traffic so the ISP cannot track, but ISP still are able to track you anyways. And also used to bypass enterprise filters and companies, and also help criminals, to hit some stuff on it. Then we have DNS over TLS, right? DNS over TLS, of course, is TCP traffic, so performance is a bit different than the UDP, so we lose performance. So there's a lot of caching going on than UDP, right? And also we got something called opportunistic, which is basically a way that to fail back from a DNS over TLS into plain DNS. So that's another thing to explore. So this is a classic estimate use of a DNS, right? You have a big chunk of DNS query, legit or not, but DNS query traffic, and then you got some tunneling traffic, and a small portion of a command and control, and a tiny portion where it's data exfiltration. That's what we're going to focus here. Cover channels. Cover channels apply to many different protocols. We are going to specifically talk about DNS cover channels, right? So we split it in three main categories, which is tunneling. Tunneling used mainly for, let's say you have free internet access in airplanes or hotels where you have a captain portal, but DNS traffic is allowed, so you can encapsulate your traffic out via DNS, or bring up a VPN, open VPN on port 53 and just do a VPN like that, or bypass corporate firewalls as well, right? Do tunneling. Command and control is used a lot in botnets and malware updates. We see an APT being quite used a lot, reversal, espionage, response state actors. Command control is quite widely used as well. And then they have data exfiltration, which is data leaks, theft, or actually unauthorized transfer from an employee outside the company. So we will try to focus on the data exfiltration part with different techniques, right? So what kind of tools we have out there? So these are all open source tools, most of it from GitHub, right? So I divided in two categories. One is for the DNS exfiltration and one for the tunneling / command and control. For example, to just to name a few, on the DNS exfiltration side, there's a PyXFill, which is a framework actually, which is being used to test from a red team point of view to test out what kind of exfiltration I can bypass or use, and of course includes DNS as well and many more. And then on the tunneling inside or command and control, we have, for example, iodine or DNS cat too. Just to mention iodine, for example, Palo Alto Firewall has a specific signature to detect iodine traffic. And there's also a tool called Mystica, which was presented in Black Hat US Arsenal this past August, which looked quite promising actually, using SOAP and a few different techniques. So this is what we have currently, right? So don't know how to start. So what we're doing is we put a pros and cons list of what we don't want based on research of how security tools work, right? And what we wish or what we would like to have, right? So again, let me just name a few. Short ETLs. Short ETLs are normally used like for F5 GTMs to load balance between data centers or resilience between regions. So they will use a short ETL, so the cache on the uptick domains will be not that big because they will be changing IP for balancing purpose or resilience, right? TXT and null. Null is just a red flag, right? Null type of query, DNS queries are actually, a red flag immediately. And TXT are mainly used internally for AD traffic, for example. Microsoft Active Directory uses a lot of TXT when you join domains, etc. And SPF records as well use TXT. So then what else we don't want? We don't want a long FQDN. It's 250 characters that you can fit in the FQDN called split by labels, which each label is 63 octets, which is basic characters, right? So we don't want that too long. We also don't want a massive amount of queries from the same IP address. That looks suspicious as well in the analytics. And a massive amount of NX domains, which is basically when you try to resolve something and the DNS will reply. Now that doesn't exist, right? Which is slightly different than timeout, right? And same domain, evil.com, you send 1 million queries to evil.com from a one IP, that will be automatically flagged as suspicious for the volume of traffic and the source IPs used on the destination domains. Now, great, we don't want that. So what we want? We want to split the architecture in data and control and data. We also want to use NS type of query, which is recursive and is commonly used. We want short labels, 20, 30 characters max, more than that. We want to use many IP addresses as a source. We don't want to use just one, and we want no answer coming back from our queries. And we want to use multiple domains, which is, 5, 10, 100 of different domains, those subdomains that we want to use. This is all what we want, right? How the tool will work that I'm going to show you is from the client point of view, you want to exfiltrate data to a server in the internet, right? But you don't have access directly to the internet. So what we're going to use here is we're going to use the internal DNS as a pivot. So the client internal in the network internally will send queries to the DNS internal, like a Microsoft AD or whatever you have. And then the DNS internal will actually be the one sending the traffic. So bear in mind, this is the way that we want to send traffic. We're not going to send from client to server traffic directly. So we mentioned about control and data splitting, right? So we want to be able to support threading or multitasking to send multiple files at the same time. If we're going to exfiltrate files from client internal to the internet, we want to be scalable, to have many domains, and we want asymmetric flows. Symmetric flow is basically the way that we use the control and data. Remember, like ADSL, so you have a half meg or 1 meg upload and 24 megs download. This is designed because your HTTP is small request, and the answer from the server back to you is big, right? With the all JavaScript, graphics, image, CSS, etc., right? So this is the same concept. We just want the control traffic to tell the client internally to the external server, I'm going to send you this file, this big, this is the name, and then we want to send in the whole file in multiple queries from using the data domains, right? We also don't want to do the sequential, like sending chunk of data 1, 2, 3, 4, because that also gets flagged. And we want to compress the data, and we want to encrypt it with a reliable hard encryption like AES-256 CTR, right? And one more, we want to add capability for retransmission, because UDP packet get lost sometimes, right? And we want that capabilities. What else we want? We want many things, right? We also want to be silenced. We want to blend in just in the network. Nobody see us. We are just normal queries, right? So we will use NS type of query, which is common to get the domain results. We also don't want any answer from the server in the internet back to us, because we don't want any stateful connections on the firewalls, right? That will be the IPS. So as they will be actually in the firewall after 30 seconds that nothing come back, the firewall will eliminate the connection from the stateful tables and put it as a H out in the logs. We want to put random times between queries, that is to add entropy. We want to limit the 20-30 characters, and spoofing. Remember I mentioned we want to have not one IP, right? So because we are able to be in internal network, and UDP is very nice when the time is spoofing. So we want to send traffic from the internal server to the internal DNS from many source IP addresses, not just ours, right? And internal servers don't tend to have a firewall. Micro-segmentation is not that common these days. And so that allows us to actually do spoofing, right, in internal network. And yeah, everything needs to be random, right? So that's all we want. We can do all this. I'm positive actually that we can do all this. So let's have a proof of life, right? So the defects actually is DNS file exfiltration. It's a tool that's in GitHub. You can go and take a look. And I'm going to show you how it works. So I'm going to do a quick demo of it, so you can see. Let me switch to the actual terminals. All right. So on the right side, I have the DNS defects server, which is actually a lab environment sitting on the back that I actually built. This could be Amazon, Azure, VPS, or DigitalOcean, anything that is in the internet. And I also have a bunch of domain or subdomains that I can control and put the NS record pointing to my server public IP. On the left side, I have the client. The client is sitting inside the network, and he doesn't have access to the internet directly, so the only way that he can resolve things is through the internal DNS. And on the bottom, I have the internal DNS actually, which I'm going to bring up a TCP dump to see what he sees from the client, right, point of view. So let's go and start the server. I will put the verbose. You can see, you specify an interface. Before I show you the data, I have 5 domains, right, as my data domains, and one, I could have more if I want to, control domain, right? So I'm going to specify the server to be verbose, the interface. I'm going to specify the data domains, which is a list of domains. Could use one if you want to, but as many use better. And also specify the control domain, which is in this case is just one. And I'm going to run my server in the internet, right? Okay, perfect, it's listening. So at the same time, I'm going to bring the TCP dump to capture the packets on the DNS in the internal DNS server. And I'm going to bring the client, verbose, specify an interface. You can specify the networks and how big you want that network, /24, 22, 21, 18, whatever. This is designed for spoofing. If you don't specify, it will take the default from the actual interface. You need to specify the data and the control, which is exactly the same list that has the other one. The server and the client should have the same list, the domain and control. And also you need to specify the file you want to exfiltrate, right? So let's say you can put a directory as well with a bunch of files. So let's run this. So what it's going to do is going to assign a file ID randomly, FF. And this is the network I'm going to use. And I have 254 IP available to spoof. And on the bottom, and there's 448, this is a checksum of the file, and there's 448 chunks that I'm going to send, right? And on the bottom, you can see random IPs sending to the internal DNS random queries from multiple domains, from random names, right? So in one of these queries at the beginning, you actually will see the control query, right, which was from my IP to the actual public one, from my IP to internal. So that's the one telling me this is a file name which calls secret DB, and this is a CRC checksum, right? It's going to compare. All right. So the server noticed there's two chunks missing. So he's going to ask for retransmission in this case, right? So how the retransmission works? Retransmission works in a way that I'm going to ask, after I finish sending the chunks, I'm going to ask the server if you need any packet that you don't have, any chunks you're missing. So the server will reply to me. In this case, it's the only case that the actual server will reply, asking like, yep, I'm missing the chunk 330 and the 24. So it's going to say, I missed the 24, so he will resend back the 24. Then the client will ask again, are you missing any chunks? And he say, yeah, actually I'm missing another one, the 330. So the client will send the 330. And then the client will say, are you missing any files, any chunks? And if there's no answer after X amount of time, the client will assume that you get all of it. On the server side, you can see that I received a file name called secretdb, when this is the CRC32 checksum, which should match the actual. So let's do an MD5 sum of the secret on the client, and it's finished in 7/v1. Let me kill the server and do an MD5 checksum of secret. Yep, I have the file, and it's the same MD5, right? So effectively speaking, in that way, you can see the traffic. If I scroll, you can see in this side, you can see all the IP address that are random. This is using the spoofing. In this way, if you do statistics, you will notice that to this subdomain, this IP make 3 or 4 queries, 2 queries, right? So it doesn't look suspicious if one IP, if like 254 IPs make 2 queries. It's not the same that the one IP doing 448 queries, right, to the same domain. Doing this way, we can. I put 5, but imagine you have 100, right? So you will have probably some IPs doing only 1 query to the internal DNS, right? And there's no traffic coming back, so there's no actually response from any of those queries. So you just will time out on the firewalls, right? Let me switch back to the presentation. All right, prevention and detection. Okay, how do prevent this, right? Well, it's quite straightforward, right? We just don't allow DNS external queries to work from internal networks. That's great, easy fix. The only condition is that doing this, we probably break half of the company, and if we have a hybrid cloud, will be a very painful thing to make it work, due to the nature of the cloud actually needing DNS resolution, external DNS resolution. So that's a tricky fix. It can be done, but it's tricky. We can also push everything through proxy, right? So effectively speaking, there's no internal DNS resolution. Everything goes through a proxy. That is another way to push it. Again, that may break stuff as well related to cloud. We can use DNS sinkholes. So all the traffic will go through a sinkhole to get analyzed instead using directly DNS. This could affect performance within the networks. Imagine you have 50,000 devices in the networks split all across different regions. So you will need to have multiple sinkholes deploys, and so it is technically possible, but it is a bit complex as well. And then you correlate all the logs, of course. Analytics, yes, that's one of the best things you can do. Using Elasticsearch, Splunk, just have a correlation. Basically all your DNS servers, internal DNS servers, should be logging everything, right? Any kind of query, from where, what type of query, and then you need to use all the analytics you can to actually try to find out patterns and trends and things like that. And all those systems works, but what you really need actually is very smart people. That's what you need, right? Looking into the analytics. Entropy analysis also work. Again, it's based on the logs, and you will try to find an entropy It could be tricky sometimes due to the nature of the, for example, I think it's Cloudflare, which have a similar 2025 random X type of a DNS, and they are valid actually, CDN sort of things. But yeah, you need to maybe do a more analytics on it. But again, same as smart people you had before, hopefully the same one doing the both of entropy and actually log analysis. And also you can switch to cloud services, right? You can also use Umbrella, Palo Alto has a service as well, Cloudflare has a service as well. That works at some extent because not everything, if your enterprise is too big, you actually cannot really, all your internal traffic go through a Cloudflare or external DNS. So you will need to try to split up your internal traffic through internally and do logs analytics and try to split up your external traffic through a third-party provider with cloud services, right? So this is kind of the preventions and detection method that we found. So it is technically possible. You can have the IPS as well. There's some anomalous DNS, which is a weird name, but the SIG IPS, for example, has a plugin for it. So there are also prevention for DAJ, which is the domain generation algorithm, which is ransomware or rats or malware use a lot, but yeah, it's require a lot of analytics. So what's the conclusion here, right? We ran through a bit of overview of DNS itself, what kind of attacks we have, or we did have before in the past, how long been there, what kind of security we can implement. Then we ran out over techniques and how do we come up with these techniques of trying to take data from A to B, right, and trying to not be catch on the middle. Well, the first thing you do is to look for the products, security products, so that are in the market selling you DNS security or firewall security or network securities, and you say, great, how this work? Okay, this box, what it does is look for this pattern matching or these things, or actually look for long TTLs or look for TXT records. Okay, great. So you put it on a list that you don't want to. So you start to work the other way around, right? You see what the security products look for, and you actually try not to match those. So this is a bit of research, test, and experiment, right? So that is the best way to come up with techniques how to bypass or not be noticed on these security products, right? What else we can do? Remember I mentioned you can have scale this, right? What about you have 50 control servers, right? So the actual control server also can be split into multiple different servers at the same time. You start a cloud Ansible, bring it up, a cloud automation, and just start a whole deployment, bring it up, exfiltrate data, bring it down. So this could automate, have multiple agents because file IDs have each file you exfiltrate has an ID, so it can have a parallel running, threading, and all those things to speed up file transfer, basically, right? And how you join all those control domains? Well, you can make a GUI and you have all of them sharing that piece of file, that each chunk. So each server will get a chunk, right? And then you have them correlated the file IDs and the aggregated in one place. So then you can actually decrypt and reassemble, decrypt, and decompress that into an actual file, right? Ideally, this was a test is running on Linux, but doesn't stop you to actually using PowerShell, for example. So if you want to be like running a different platform instead of Linux, you can run it in Windows, right? So there's all sorts of things that you can go from here. The whole idea of this is to give you an introduction of these techniques, and I would like you to start to think how you can take these techniques, modify, adapt, and implement in a different way. So maybe you have better ideas to use some techniques in a different way. So that's the whole idea of this, is to give you an introduction of the research, text, experiment, right? See, it's all about it. So I would like to say thank you for watching, I got my details on the bottom. So if you guys want to, reach out and give some comments, or I put the actually the tool that I show there is in GitHub, so you can change it, modify it, raise PRs if you spot something. It's made in Python 3. It has some libraries. I'm not a native programmer, so it's done with love. So it can be improved for sure. So you're welcome to contribute if you want to. And we probably will go to be moving to the Q&A session after this. Thank you.